Technical briefing, India. This year we will be in India for the second time for the F1 World Championship, and it is obviously new, but we have some information from last year. The track is a mix of longitudinal and lateral sections, although with a slight prevalence of lateral ones. Last year it was pretty dirty every day because of the construction works that were still on site, and this obviously requires some extra care when we prepare the setup of the cars. India falls in average for some of the parameters. For example, is a low bumpiness circuit. The curbs are not really an issue. What requires some attention is that generally it's quite dirty because it's not used very often. Last year was particularly dirty because of the construction works which were on site. There are two relatively long straights, but also some twisted corners and some typically Tilke signature corners like turn 10 and 11, where the front tires for sure are having quite hard times. As I said, there are some corners in the Delhi circuit which could be quite hard for the front tires, and this requires particular attention in the setup of the suspension of the car. So I will try to explain you some of the changes that we do when you hear on the radio ride height change or stiffness change or anti-roll bar change. Okay, what we see here is the part of the front suspension of the car, pretty much from the chassis to where the wheels are. First of all, what is the purpose of a suspension system? The primary purpose is to keep the car off the ground, to make sure that the only thing which is in touch with the ground is actually the wheel. Well, it's also used obviously to absorb all the bumps which are on the track, the curbs, and this is not just for driver comfort, which we only care relatively in a race car, but it's also because the more we can be compliant with the car towards the track, the more grip we can extract out of the tires. So this is a very important part of what we call the mechanical grip, to distinguish it from the aerodynamic grip, which is also obviously even more important in a Formula One car. So on one side you want to have all this system to be very compliant with the road, to be soft, because this would guarantee that basically, as you might have seen on TV sometime when they show a close-up of the wheel is very free to move, to follow all the bumps and all the asperities of the track. But if you go too much on the other side, you might have some problem. First of all, the driver will report a lack of reaction on his input on the steering wheel, and you might have heard that on the radio sometimes. And the other problem is that the suspension works in principle like the one of a road car, but there is a very big difference between the suspension in a road car and a suspension in a Formula One car. The suspension in the road car only needs to hold the weight of the car. Suspension in a Formula One car has to hold a variable weight, because on top of the over 600 kilos of the car, with speed you have the downforce, the aerodynamic force, which is going to push down the car, and so the whole suspension must hold like 3 times the weight of the car, and when you are at high speed, high downforce configuration. This is why there are some details that I will go through in a minute that will show you the differences and why there are these differences between a Formula One car and a road car. So let's talk about the front of the car. So when the car is running, the wheels are in touch with the ground, and the chassis, in an ideal world, the wheel don't move, and the chassis just follows through the suspension, follows, and basically the wheel absorbs all the bumps of the track. So what are the components that allow the car to do this as well as possible? First of all, we need to think and what kind of movements there can be in an axle. Basically, these movements can be simplified to two movements. One is when, let's say, the chassis moves at the same time in relation to the two wheels, which is called a heave movement. And one is when the chassis moves in a different or opposite direction between the two wheels, which happens in two situations. When the car is in a corner, there is this movement which is called roll, by which let's say the chassis rolls against one of the wheels and away from the other. And the other situation where the movement is not exactly the same is if one of the wheels hits a bump or a curb, and then it's a single wheel movement. To be able to tune to how we like the car, obviously there cannot be only a single element taking care of all these different things. So normally there are, in a normal car, there are two elements that take care of that, and in a race car there are three, which we'll explain in a minute. So in order to cope with the different movements of the car in relation to the wheels, we have one system which basically only takes care exclusively of the roll movement or the single wheel movement, which is what we call anti-roll bar. Basically, it's a system. It's a bar. It's a torsion bar in some cases, or some different kind of linked bars in other systems, that is neutral when the two wheels are moving together, so when we are in heave condition, but it kind of reacts when only one of the wheels is moving, or if the car is actually rolling. This is why it's called anti-roll bar. Why do we need this, and why don't we use the same system to prevent the roll? Because if we were using the springs or the torsion bar that we normally use to prevent the heave also for the roll, it would lead us to a kind of a compromise by which we should be too stiff in one of the movements to be able to compensate also for the others. And in general, it is always better to be, well, how we say, decoupled, so that we can have better control in each one of the different movements of the car. Finally, these are all things that exist also in road car. One specific element which exists pretty much only in race cars which have wings, which have downforce, is the so-called central element or third element. What I will show you here now is a part of the rear central element, which is the rear central element spring, because it's bigger, it's easier to see. Basically, this element does pretty much the opposite of what the anti-roll bar does. We said that the anti-roll bar only acts when the two wheels are moving not at the same time and nothing in other conditions. This is linked in a way that it only works if the two wheels are moving at the same time, and if we are in roll, basically it does nothing. When we are at the track, and you might have heard this on the radio, we adjust the ride height of the car very often. This is done for aerodynamic reason, or sometimes simply because we are running too low and we need to hold the car off the ground a little bit more. What we can see here is the one possible way, the way we use to adjust the front ride height. You see, this one is called push rod, and basically connects through a rocker and a torsion bar, connects the front right wheel in this case to the chassis. And so basically this is a rod which defines how high the car is sitting compared to the ground. And if you look here, you will see that there are some shims that are of any thickness that we can decide, and they are stacked up so that the race engineer can define and decide how many must be in to guarantee that the ride height is exactly where he wants. Just to give you an idea, the the resolution at which race engineers adjust the ride of the car is in the range of the 0.3-0.5 millimeters.